Okay, just as we get fired up, good morning, everyone. My name is John Carrier. I'm a senior lecturer at the Sloan School at MIT. And how many of you heard of the concept of system thinking or system dynamics? So how many of you have heard of supply chain? Actually, why this group is important at MIT is it was developed by Jay Forrester. He was an electrical engineering professor in the 50s. And he had a problem. The Navy asked him to come up with this system for basically controlling our nuclear weapon systems, which became SAGE. And he looks at what the Navy is asking for, and he says, this is never going to work with vacuum tubes. So he went out in a small team, basically invented magnetic core memory, and that patent's made more money for MIT than any other patent since. So then after he did that, and this is in the early 50s, that system's still working today. It was the most successful project the Navy's done to date. So in the mid-1950s, he's like, all the interesting work in computers is done. So then he decided to go over to the Sloan. You can do that when you're a genius, right? So he decides to go over to the Sloan School. And they had this group funded by Alfred P. Sloan on industrial engineering. And while he was there, a company came up to him from Lexington, Kentucky and said, we got this problem in our factories, right? And we sell white goods, dishwashers, refrigerators, washing machines. Some weeks, like we're full out in the plant, like we're running 3 shifts, we can't keep up with demand. And then other weeks, we can barely have enough orders for 1 shift. Now, you see what the problem with that is? Do any of you buy dishwashers and stuff like this, right, with this massive oscillating demand? And so, to make a long story short, what happened is all that oscillation was caused by internal company dynamics. Poor information, batching and queuing, and all these bad things that probably you heard a Toyota projection system was about to reach. And he was asked by this company, come on up and we want to do a simulation, or give us an exercise. So he says, okay, when are you coming to MIT? He says, next week. So they come up and he developed this simulation on a bingo table with bingo chips to basically play what was really the first supply chain simulation. We don't call it the refrigerator. We still play at MIT, and every business school plays it. We don't call it the white goods dishwasher game. We call it the beer game. Anyone heard of that? So anything you hear supply chain or whipsaw, this is where it comes out of. And one of the challenges I'm really struggling with, we want to work together is, companies, we see AI, we'll reduce our employee base. The real money is in reducing the oscillation of that system and actually getting things to where they need to at the right time. And just connecting to today's modern, when you think about digital twins, I did spend some time with Jay Forrester when he was 95 years old, and I came out a changed person. And one of the things he said to me, if you're not simulating, you're wasting your time, right? So all these lessons that are 70 years old, we're seeing them repeat themselves. And if we understand these basic principles, we'll have a better implementation. Okay, so I teach students, and I'm teaching all the time. Everyone's changed. People get bored with lectures now. And plus, you've had a ton of great information this morning. So let's start to keep this interactive. So when I start showing points and back and forth and ask, feel free to speak up. We'll knock it back and forth. So here's my principles. I never thought when I was going to do graduate and academics and study 6 years doing a PhD that I'd spend most of my time focusing on inventory, right? But what is inventory? Especially work in process, it's basically how your organization absorbs uncertainty and ambiguity, right? And if that ambiguity or uncertainty is created because of poor practices, then your competitor is going to do better the job than you are, and you're going to be in financial pressures. Not only, and I spend about half my time actually at companies doing operational improvements. I only teach half the time, and I immediately go to your work in process because there's the symptom. If your future doesn't look a lot like your work in process, you're going to have this fun event with the accounting department. You know what that event's called? A write-down, okay? So that's the first place you want to look. And all these things, we're buying AI agents and this and that. I go, how are we affecting today's current work in process? Because that's a symptom of the quality of our current process, and that's where the money is, right? And third, it really encourages, enlightens the the front line. Because you know what the front line really cares about? Is this company producing healthy cash flow so we can maintain our jobs? That's where I start, okay? And that approach hasn't changed since I started, but AI has changed how we're doing it and how quickly we get there. So first is deferred maintenance is an organizational, not a maintenance problem. What do I mean by that? I mean, when you have a discussion between operations and maintenance and your big customer, Walmart, wants this product next week, who gets priority? Operations or maintenance? Pardon? Operations does. Okay, we all agree. And really, it's because it's a decision to prioritize other activities over scheduled maintenance. Now, AI predictive maintenance could make this much better, but it could make it much worse or some mix between the two. And I know you've seen a lot of great talks about how to make it better. I just want to talk about that bottom tail, that if we fix that piece first, it sets us up for success, and those are all system dynamics principles. Your vendor's actually trying to help you, right? And I think one of the things you want to do when you bring your vendor on is get there early. And also, I'm a third party, so I work between organizations and vendors. And I see, there's always mismatch where you have to talk and agree where's the Venn diagram where we add value to each other. And obviously, vendors and services, we're in business to provide our products. But on the other hand, if the companies won't show where our problems and symptoms are, there's no way to tailor the adoption to that company. So as a company, you have to also be clear that if you're not going to discuss your symptoms, you can't be diagnosed. And then third, I worked in cybersecurity for about 2 years. And well, you know what's true in cybersecurity? You need to make friends with your vendor before the hack, okay? And so we're moving towards a one-off sales to multiple sales where it's sequenced, where everyone's really benefiting and making money every 3 to 6 months. We're gonna have to change our thinking around that. And then finally, I really think we need to treat maintenance as a human endeavor. Now that I come from the chemical industry, so people don't build molecules, machines do, right? And I work in machine parts, and people don't make those parts either, the machines do, but the people take care of those machines, and that's where I really put most of my focus. Now, none of us can disagree that proactive maintenance works. This is work by John Sturman. This is 15 years old, 20, and using proactive maintenance, they went from, this is an actual plant in Australia. They had 91 employees, and they had 83% uptime. They originally started they cut their staff by 10, and their uptime stayed constant, right? So that's fantastic. But when you actually put that extra 10 employees, and this is line number 3, by actually being proactive in addressing several projects, they increased uptime by 10%. Now, we don't have to know the exact math. When I'm in $1 billion facility of capital assets, what's worth more, 10 employees full-time or 10% uptime? It's got to be 10 or 100x, right? This is Tom Siebel. He talked about predictive maintenance as the killer app of industrial engineering, and I'm not going to go through the video, but how much value could add. Talked a lot about how AI and all these things were going to add value. Does anyone know the problem with this video? It was shot in 2017. And now that's C3 AI stock, which is basically 12% of what it was 5 years ago. But on the other hand, you look at Palantir, and it's now 6 times. So it's not simply, we know these tools and techniques are going to work, but how you apply it is very dangerous. Here's an example of how not to do it. This was GE Digital. They were asked to help out an oil and gas company with their unmanned production assets. This is the Gulf of Mexico, or Gulf of America, or Gulf of something. And all they wanted was, what do you really want? They used to have to send 2 people out in a crew boat every week to get like a few temperature measurements, some pressure, vibration, and mostly tank level. Those are really critical, right? So working with GE Digital, they proposed a solution with 18-month time frame They came back 36 months later with 5,000 features, none of which addressed the company's original problems. And I think we all know what happened to GE Digital, right? And there's from their CTO, our engineers thought the client's problems were too boring. So all I'm trying to say is there's real money out there, but you actually have to go for the money rather than the cool technology. And I know you've heard this before. This is at the $5 billion mistake. So the CEO of GE at this time was Jeffrey Immelt. Does anyone know the name of the new CEO from GE? Larry Culp, who I mentioned, that gentleman back there asked the question about Larry Culp. Remember that gentleman? Because if you bought stock like I did when Larry Culp took over, you'd have made a fortune. So if you don't do any of this stuff, you've got to have this culture of we're going to fix things together, or else you're going to achieve not great results. Now, I've worked offshore. This is a high risk, high consequence, high profit industry. And this was to do maintenance on blowout preventers, which we've all heard of. Does this look familiar to anyone if I went into your shops or your company's shops? That's what it looks like. Is AI going to fix that? Right? So you need to put the system in order because basically the system won't let the operators do what they need to do. So that's, I'm no blowout preventer maintenance expert. That's my expert application in 10 minutes with the duct tape, right? And these are all the mystery tools that we have. So the first thing is as you move up this level from break fix to whatever happy level of maintenance maturity you want to go to, the first thing is, start where you are and start setting the workspace up so that people can do their jobs. Now if you bring in, well, we're missing this information, we'd like A, B, and C, maybe now there's an application for an AI agent. But remember, everything has to move in sequence, and you always pay attention to the system first. So I always like to introduce a historical context to what I do. We all know, I have to ask these days, we all know that's Abraham Lincoln, don't we? And he's famous for saying, 7 days ago, we deferred scheduled maintenance, right? And then, right? Why did the plant, that all this stuff, it's because we deferred. Now, why do we defer scheduled maintenance? And a lot of us are going to say, well, so we're pretty experienced people. We've been out in the field. We understand how operators. Some we think, God, if we only could have predicted that was going to fail. And I have a couple of videos. One of them I may have the chance to share. If there's steam coming out of it, or it's turned cherry red, or it's making some squeaking sound, I can predict that's probably going to fail, right? So before we get into, and why? It's because our scheduled maintenance is too slow. So one of the key points of this speech is if you walk in and someone's asking for predictive maintenance, ask them for their backlog. And question, if we have a maintenance backlog and we say, let's add predictive AI maintenance, is that going to make the system better or is it going to make it worse? And why is it going to make it worse? Because it doesn't address the root cause, and in fact, it's going to make it worse because you know what predictive maintenance is going to do when you put it into a poorly performing plant? Predict more maintenance tasks. And what does that do to the staff, right? Now you just put an immense amount of pressure on them. And I did promise you there was a winning formula. I'll show you the formula. So the behavior that we see of people on the ground is a function of them, the people themselves, and the system they belong to. And we love to, when you see somebody doing something that goes against the plan or the way we define how we do things around here, who do we like to blame or what? I sort of gave it away. The person, right? The operator, the actual that. Now, if you are forced to do something wrong because out of the definition, because the system made you, who do you blame? The system. That's called the fundamental attribution error. We blame others when we see a mistake, and when we do the same thing, we blame the system. So what we want to do is actually realize most of the behavior you see, especially in large systems, it's 90% the system and only 10% the people. They're trying to behave within the system's constraints. So what you want to do is you have to change the system, otherwise you're going to get a few interesting projects. And if you engage the people in changing their own systems, that system will then change the people. And then we'll go into this virtuous cycle. And where we are now is this is a continuous improvement loop. So now I think the right place, I treat AI like a virus, right? Where do we inject AI in small pieces to basically accelerate this loop, right? And if you already have a culture of continuous improvement, this is going to go right in. If you don't, either you're a monopoly or you'll go out of business if you don't have one, so build one. Now, everybody loves data, okay? But let me tell you, when you actually think about data, there's actually three parts that I have. I have data and a model and the system. And here's how the three parts fit together. One, the model's how we expect the system to work, right? Now that could be in our heads or it could be a simulation or previous experience. The system is how it actually does work. And the data I'm looking for is the difference between the expected behavior, which is what the model put out, and what the system did. And if there's a difference, we're going to track that down, and if the system needs to be improved, we do. So whenever, do you also have this challenge? God, if we had more data, we could fix this, right? I really want to know which data, right? Because, and then sequence it in your adoption. So really here's, we know that AI works, but is your system going to allow it to work? Okay. I'm going to, excuse me, I'm going to show you one slide, and then what a critical problem this can be. This is what I want to avoid. I actually have worked at this refinery, and we achieved some great progress, but this unfortunately happened 10 years later. They had 3,000, almost 4,000 alarms in one day, an unsent email, and it unfortunately led to 2 fatalities. And what I want to see is when we start to implement new technologies, how do we do it in a way that massively reduces risk quickly rather than overwhelms them? Because if we don't do that, this is the classic, this is Kingman's equation, and all it says is when a system gets near its capacity, it explodes, right? So have you ever gone to the coffee shop? When it gets really busy, the line explodes. When you drive in traffic, you get there on time, but when you get to 90% capacity, everything breaks down. And when you stress your staff, you give them too much work to do and not enough time, what happens? It breaks down. So how do we actually use these new technologies to increase the actual capacity that I have by giving people what they need? And I'm going to wrap up on this slide and we'll take some questions. This is an example I did, and my real point is here is when I looked at the first step we need to do before we start going in predictive maintenance, we need to speed up scheduled maintenance. How much time in general do we spend looking at scheduled maintenance and saying, can we do 50% more tasks in this scheduled maintenance slot? Not so much. And so I was doing a project with 7 plants in Latin America across a packaged goods factory. So I said, they wanted me to come in and put in a predictive maintenance system. I go, we got to fix this first. So we gave the team gave them GoPro cameras. They stopped the plant every 2 weeks for 12 hours. And I said, look, let's go through 3 or 4 cycles, and I fully expect we can get 50% more maintenance tasks done in that period, right? And we're talking 60 people, right, doing this. And you know what happened? First time out of the gate, we got 50% more tasks. First time, right? And what do you think that says about the system? And just a little bit of an example here. Within 20 minutes, I already knew we were going to save a lot of time because when SAP printed out, when they came in the morning to do their tasks, they each got an SAP generated spreadsheet of 200 tasks. And then the 6 lead operators were sitting there going through pencils separating out, these are my 20 tasks. Then their staff is sitting around waiting for them instead of preparing because they don't know what's coming. So that value, if you start looking for the time delays and the losses first, then apply the technology to fix the system. Don't buy the technology first and apply it to the problem. Okay. So I could just, my whole point is you can read the New York Times or the Wall Street Journal, and you can find example from this, from Ford Motor, from Boeing, et cetera, and so on. And so the last thing I want to do is when I work with companies, in the morning, we have to work and do learning and training with the maintenance staff and team in the morning, and then we go out and actually fix these things. So just to conclude, I think maintenance status has to, I think technology has a much higher status in the organization than maintenance, right? So if you don't fix that maintenance technology gap, you're not actually going to get your real value out of moving up that chain. I don't want to buy new technology. I want to buy the right to make decisions, and I want to buy a workspace that supports the best performance and not just shiny tech. Question the more data is better approached, and then get everyone engaged so everyone helps each other. And then finally, we really should start thinking about maintenance as a human endeavor, right? It's really a profession. Those people are exceptionally skilled. So start there. Okay, if we have a little time for a question or two, I'd love to hear your responses or thoughts.